right out. Then turn the third foot screws. Then turn the third foot screw to bring the cross bubble to its central position, and in this way we repeat this until both the bubbles are centered. So, in this way we do leveling accurately with the help of the foot screws or leveling screws. Third part is, or third step is focusing. Focusing is also done in two steps. First step is focusing the eyepiece for distinct or sharp vision of the crosshairs at diaphragm, and second step is focusing the object glass for bringing the image of the object into the plane of the diaphragm. So, focusing is also done in two steps. So, first step being the focusing the eyepiece. Direct the telescope towards the sky or hold a piece of white paper in front of the telescope, move the eyepiece in and out until a distinct and sharp black image of the crosshair is seen. I once again repeat, direct the telescope toward the sky or hold a piece of white paper in front of the telescope, move the eyepiece in and out until a distinct and sharp black image of the crosshairs is seen. Second part is focusing the object glass. Direct the telescope toward the staff and turn the focusing screw until a clear and sharp image of staff graduation is obtained. One point to be noted over here is that we have to focus the eyepiece for crosshair once only, and the focusing the object we have to do once and again for every type of object. So, parallax is completely eliminated if there is no change in the staff readings. When the eye is moved up and down, so that is called as parallax. Parallax is completely eliminated if there is no change in the staff readings when the eye is moved up and down. So, this is the figure showing how we do the leveling with the help of a foot screws. In the center we find the bubble is there. We use how we use A and B, that is one set of the foot screws, and in the second figure B we use the third screw. So, this is how we do temporary adjustment, that is leveling with the help of foot screws. So, next part is finding difference of level of 2 points. How we do leveling in the field? We have to find the difference of level of 2 points, and there may be two cases. Case 1 is there when the 2 points are so situated, that is the case is there 2 points are so situated that both of them are visible from a single position or single setting of the level. In this case, the level is set up approximately midway. The level is set up approximately midway between the 2 points, and the reading on the staff held at each points are observed, that is readings are taken. The difference of the two readings, we subtract one reading from the other, being the difference of the level between 2 points. This will show the difference of the level between 2 points. The operation of finding the difference of level in this case, as it is so simple, it is also called as simple leveling. When the 2 points are so situated that we can find the difference of level from single setting of the instrument, this type of the operation is so simple, that is it is called as a simple leveling. Second case may be as a first case, we can show it with the help of a figure on the right side of on your monitor. Let A and B be the 2 points as shown in the figure whose difference of level is required. Whose difference of level is required, the leveler, that is the person leveling, sets the instrument at a suitable position, say O, on the ground approximately midway between A and B and performs the temporary adjustment. The staffman holds the staff vertically upon the first point A, that is, staff is held at the first point A. The level man directs the telescope towards it and takes the reading. The staff is then held on the second point B and a second reading is taken. Let the respective readings on A and B be 1.120 meters and 2.460 meters respectively. Both the readings are taken, and when we will find the difference, that difference will give the difference of level between A and B, which will be 2.460 minus 1.120, and which comes out to be 1.340. That is, in this way we can find out the difference of the level between 2 points which are so situated, that is, they can be seen from single setting of the instrument, and which is called as simple leveling. We can subtract both the readings and find out the difference of level between them. And second case is there, when the 2 points are so situated as is being shown on the figure on your meter screen. First one is the difference between them being too large, that is, difference between the points is so large to permit reading of the staff, that is, staff reading is difficult with limited optical power of the telescope of the instrument, and the difference between them being too long to permit reading of the staff with limited power of the telescope. And second is they cannot be sighted from single position of the instrument due to intervening obstacle, that is, some obstacle might be there in between the 2 points. The same second case is such that there can be an obstacle in between 2 points. Or third one is the difference of their level being so large, that is, difference of level is too much. In all of these three cases, it is necessary to set up the level in several positions, that is, we will set it number of positions as is being shown on your monitor screen, as 1, 2, 3 positions are there. We set the instrument 3 times or 4 times, depending upon the time, number of times we can set the instrument, and to work in series of stages, that is, we will find out the difference of level in series of stages, which is called as a compound leveling. So, first one is known as simple leveling and second case is known as compound leveling. As shown in figure, let A and B be the 2 points whose difference of level is required. The difference of level is determined by observing that from A to a convenient point C and then proceeding similarly from C to D and from D to B. The instrument is therefore first set up in such a position as in position number 1, from where a staff held at A can be read and a clear forward view obtained. After the back sight on A is taken, the staffman selects a firm point C on which he holds the staff and 4 reading is taken. Thus, the level difference of A and C can be found out. Then the instrument is transferred to position 2. After the instrument is leveled, the staff at C is again shifted so that level of C may be compared with that of next convenient point D. The process is repeated till the end point is reached. In the particular case, the 3 setting of the instrument suffice to reach the end point. The difference of level between A and B is equal to the algebraic sum of difference of levels of point A and C, C and D, D and B, or equals the difference between the sum of the back sides and the sum of the 4 sides, that is, back side minus 4 side. If the difference is positive, it indicates the point B is higher than the point A, while if the negative, the point B is lower than the point A. Thus, if RL of A is known, the RL of B can be found out by the relation RL of B is equal to RL of A plus back side minus 4 side. So, level book. The leveling field book notes are recorded in a notebook called a level book. The pages of level book are printed in a tabular form so as to facilitate booking of readings and reduction of levels. Reduction of level. There are two methods of working out reduced levels of points from the staff readings taken in the field. First is height of instrument method, and which is called as collimation method, and second is rise and fall method. So, these are two methods, collimation method and rise and fall method. It consists of finding the elevation of the plane of collimation, that is height of instrument, for every setting of the instrument, and obtaining the reduced level of the points with reference to the respective plane of collimation. To start with, HOI is calculated by adding the backside to the RL of the starting point. The reduced level of the intermediate points and the first change point are then obtained by subtracting the respective readings from the height of instrument. When the instrument is shifted, a new plane of collimation is set up, and the height of which is calculated by adding backside reading to the RL of the first change point. The reduced level of the successive points and the second change points are found out by subtracting the staff readings from the new head of height of instrument. The process is repeated till all the RLs are worked out, and then arithmetic check is applied. Second is rise and fall method. In this method, the difference between consecutive points is calculated by comparing each point after the first with that immediately preceding it. The difference of their staff readings indicate rise or fall according as any staff reading is smaller or greater than at the preceding point. The RL of each point is then found by adding rise or subtracting fall to or from the RL of the preceding point. Second method is rise and fall method. It is a staff reading. If a staff reading is greater than at the preceding point, then there is a fall, and if smaller, there is a rise. So, then we perform the arithmetic check, which is sum of backside minus sum of foreside is equal to sum of rises minus sum of falls is equal to last RL minus first RL. So, how we book the staff readings? First is the reading should be entered in the respective column as soon as they are taken and in order of their observation. The first entry on the level book page is always a backside and the last is a foreside. Fore and back sides of change point should be written in the same horizontal line. The height of instrument should be written in the same horizontal line opposite to the back side. While carrying forward the reading from one page of the level book to the next, if the last reading is an intermediate site, it is entered in both IS and FS columns on this page and IS and BS column as first entry on the next page. Brief description with the neat sketches in respect of benchmark, change points and other points should be given in the remaining columns. So, this is the page of a level book, how we perform this collimation method. As on point A, first reading is backside, last reading is 2.090 and in between 1.495, 1.760, 1.890. So, these are the readings entered in the page of a level book. Similarly, by rise and fall method, if the fore reading is greater than the previous one, then there is a fall, otherwise it is a rise. So, these readings have been entered in the respective columns and we will perform arithmetical check as sum of backside minus sum of foreside is equal to last RL minus first RL. All these values should come equal. So, in this way we can book the readings in the page of a level book. So, these are some questions. Define following: backside reading, foreside reading, intermediate side reading, height of instrument, reduced level, benchmark. Compare the rise and fall method with collimation method for calculation of RLs. Third question, write short notes on parallax, focusing. Fourth question, following consecutive readings are taken with a level. The level was shifted after 4th, 7th readings. First readings were taken on a benchmark of RL 250. Draw the page of a level book, enter the readings and calculate the RL of all points. So, this is all about today's lecture. I hope you must have benefited from my lectures. Thank you once again.